and welcome to Saturday's edition of Cracking the Cryptic, and what should really be called the Blobz edition of Cracking the Cryptic. Blobz, of course, is a constructor we've featured many times before, always with very popular puzzles, and today I can reveal is Blob's 59th birthday over there in California. So Blobz, many happy returns. I will tell you, actually, your brother Timothy wrote to us and said you'd really appreciate it if we gave you a shout out. We are going to do better than that. We are going to solve not one but two Blobz puzzles, I hope, in this video. We're going to solve the puzzle on the screen, which is the main puzzle, and this is called 159 Region Some Line, which rhymes, I suddenly realise, but I guess 159 includes 59, the magic number of the day. We're also going to attempt to solve this puzzle, which Blobz also sent us as a tribute to the planet Pluto, and I'll explain more about that in a moment or two's time. Anyway, let me grab my list of things to talk about today. I'm going to tell you what I've been doing for the last few days. I've been competing in a golf tournament, actually, called the Cyril over there at Warpleston, one of the finest courses, in my opinion, in England. Golf architect was Abercrombie, who also designed possibly my favourite inland course in the UK, the Addington. Anyway, big shout out to my teammates who somehow dragged me through to the semi-final, where we were very unfortunate to lose yesterday morning. So yeah, particularly Roger, fantastic to play with you, my friend. And yeah, I doubt many of you know what the Cyril Grey is, but it's scratch foursomes, an old school competition, and it was the first time I've played in it, and it really was a lot of fun. So thanks to everybody who I've met and talked to, and who's been my teammate over the last few days. What else can I talk to you about today before we get puzzling? I am going to say I've got some birthdays, actually. I've got a few birthdays to do. I'm going to start with McLean over there in Seattle, Washington, who turned, I think, 36 yesterday. I may have got that slightly wrong, but I think that is the correct birthday, McLean. And I know this because your mum, Lynn, got in touch with us. Oh, and Lynn is over there in Dallas, which is an awful long way away. We had a lovely email from Lynn, and I know that she really appreciates the fact that the two of you watch the channel and can sort of share stories about the puzzles that you try every day. And then, well, actually, McLean also has a I'm just going to read out the name of McLean's podcast, which I haven't listened to, but it did amuse me because he has a podcast with his brother, which is about movies, and it's called One of Us is Always Right, which struck me as being very similar to the relationship I have with my sister Hannah, where one of us is always right and we never take the same opinion on anything. So by definition, one of us is always right. Anyway, McLean, happy birthday for yesterday. Next, Patricia, I think, or Patricia. 20. I don't know which day this week you turned 25, Patricia, but you did turn 25 this week. I know you're over there in Poland, and you're coming up for the 5-year anniversary of your relationship with Bartome. And I may be saying Bartome's name incorrectly. Almost certainly am, in fact, because I have no idea how to pronounce it. It looks very complicated, but I'm going to go with Bartume. Bartume. Might be right, might be wrong, but anyway, Patricia, I hope you have an absolutely brilliant day, and I hope the two of you are able to celebrate your relationship with some cake. Next birthday, another belated birthday, a very important belated birthday, to none other than Sven, the programmer behind all of the software we use, who allows us to basically play these puzzles every day. Sven turned 44 this week on the 20th, so I think a fellow Gemini, Sven. And you sent me a picture of you and your girlfriend enjoying a burger on the beach. It looked very fine indeed. And Sven, you know we love you. I think the whole sudoku world loves you. And I'm not sure actually if I'm not sure. I don't know how to make it happen, but apparently Sven's little icon that sometimes pops up when you launch a puzzle has had chocolate cake on it for this week to say it's Sven's birthday. So Sven, happy birthday! I hope lots of the Sudoku community watching this video drop you a comment to wish you many happy returns. And then finally, Mark, it's your birthday today. And Mark, I know you as Felicity's dad, I have to say, because Felicity wrote to us with a lovely email about how much you'd appreciate a shout out, but Felicity forgot your name, so I had to ask her. I had to ask her to confirm, because she referred to you as her dad in the email, obviously. And I know now that you are indeed Mark, and I hope, I know you've been dealing with long COVID, which is a complete and utter pain. I hope that you are getting over that, and that today is a day full of happiness and cake, of course. And finally, I'm going to just share with you a lovely email that we had from one of our viewers, Tony. And I wanted to share this with you because I know a lot of people come to Sudoku variants and they think, and they might even watch these videos and think, well, I enjoyed watching the videos, but I could never do that. Well, let me just share with you the email we got from Tony this week. He says, I had such a profound experience watching your videos that I had to thank you in the most personal way I could. I've always loved logic puzzles, but I've always had a very hard time finding good ones, and I have exhausted all supply of nonograms, Minesweeper-like games, and Sudokus I could find, and what was left was starting to feel boring. But then I discovered your channel. I've been watching for maybe a month now, occasionally attempting puzzles with a video short enough that I thought I could finish it, but much more importantly, learning from the way that you solve puzzles. At first I could only solve gas puzzles, but thanks to you I've been able to solve harder and harder puzzles. And then comes the deeply profound experience I mentioned earlier. At time of writing, a bit more than a week ago, you released a video about a Pac-Man themed puzzle, which, being a fan of video games, I had to give my best shot, even though the huge rule set and video length intimidated me. And finally, after wrestling with it for 2 hours, I managed to solve it. This was already a huge step for me, but then your video yesterday was called That's No Sudoku, and I scrounged up the courage to attempt this before I watched the video. Because I liked the last Philomeno puzzle that you'd featured. After 4 hours of beating my head against that puzzle, I solved it. It was so extremely far beyond anything I had ever solved before, I can't believe I actually did it. And that is all thanks to you. I started as a total novice to variant Sudoku puzzles, but you've taught me so much about them and how to approach them that my confidence in solving these things is higher than it has ever been. I cannot thank you enough, because finally solving that puzzle after 4 hours was the most brain-expanding thing I have ever done, and the rush was unprecedented. You have a fan in me for as long as you keep making videos. Well, Tony, the kind words about Mark and me in that email we can put to one side. You need to, we need to take a bow to you and applaud you, frankly, because this sort of thing is something I absolutely love. People making their brains better, and there is no better way, in my opinion, than these sorts of puzzles. They are all absolutely wonderful. And we're gonna get solving in a moment or two. Our planetary fact now. This is celebrating the Planet Suite, which is our Sudoku, our monthly reward over on Patreon. Comes from none other than Blobz. It's totally appropriate that Blobz should be the one behind the fact today, and it's about Pluto. And it's a fairly straightforward fact. Pluto was discovered in 1930, and apparently it's primarily made of ice and rock. And it is only 1/6 the mass of the Earth's moon. I love the fact that when you talk about planetary facts, you have to refer to the Earth's moon, because if you just said moon, it could be any number of other moons that, of course, orbit the planets of our solar system. Anyway, Blobz is so taken with the planet Pluto that Blobz sent us this puzzle, which is about the planet Pluto and features a rule set which is very similar to the one on the main puzzle today. So I thought we might have a go at it. It's only a 4x4. How hard can it be? That actually might be a silly thing to say, because I have based 4x4 puzzles before that are difficult. But I think looking at it, this one ought to be doable. So normal sudoku rules apply. Place the digits 1 to 4 once each in every row, column and box. And then these blue lines are region sum lines. So the digits along a blue line have an equal sum n. Within each 2x2 box the line passes through. Different lines may have different values for n. So what that means is, if we look at this line, let's just highlight it. We know that this line goes into this 2x2 box in just one square. So this square has to equal the sum of those two squares, which are the two instances of the line in this 2x2 box. Let's do this one. So that one, the way that one will work is that this cell has to equal the sum of those two. And then this one is a bit different because this only has one instance of itself in this box, one instance of itself in this box, and one instance of itself in this box. In other words, those three cells there actually have to contain the very same digit. So this is what we're going to have a quick go at now. Do have a go. I will put a link to this one under the video. Let's get cracking. Now we're only dealing with the numbers 1, 2, 3 and 4, so I think the way to start this is just to notice that those two squares have to be, they can't be 1 or 2, can they? Because each one is adding a 2, we're always adding two different numbers together. So if we put 1 and 2 on this line, that would give us at least 3 here. And the same thing happens there. So this has got to be a 3-4 pair. This has got to therefore be a 1-2 pair. Then mad Sudoku skills allow us to just enter in these digits. Oh, these digits are all the same as well. So we can put 1 and 2 into this square. 3 or 4. Oh, I had a thought. It must be quite likely we get a 3 in the corner for a puzzle this size that only includes 4 different digits. Right, how are we going to do this now? Do we have to... Oh, hang on, I see. Yes, you can't. Where do you put 4 in this box? That's a straightforward question. You can't put 4 on the line or this will be at least 5, so 4 goes in the corner. And my hopes... Oh no, I am going to get a 3 in the corner. I was just about to condemn the puzzle for not allowing me to put a 3 in the corner, but putting the 4 there does give me a 3 in the corner. I don't know... Oh, it does. I wasn't sure whether 3 in the corner would work in a small puzzle, but of course Sven has made it work. So that's 3 in the corner. That's 3 in the spot. Light and losing its religion. So these are from 1, 2 and 3, and 3 is on the line, look. So 3 is on the line, this must be 3 and 1. So this has got to be 2, 2, 2, that's 1, that's 1. This is 4, this is 3. This must now be a 1, 2 pair, which we can fill in. Fill in the 3 and the 4, fill in the 3 and the 1. Okay, that was straightforward. 1 minute 47 seconds. One of the fastest puzzles ever on the channel. And 3 people only have solved this. That's not many. Save replay. Well, that's another innovation that Sven's introduced, I think. I don't know what that is. But anyway, now we're going to get on to the proper puzzle. This is Blob's birthday present from Cracking the Cryptic, solving this puzzle. 159 region sum lines. So let me read you the rules. Normal Sudoku rules apply. So this time we've got a 9x9 grid. Digits in column 1 indicate the column in which the digit 1 appears in that row. E.g., if row 4 column 1 is a 6, let's put 6 in, then row 4 column 6 is a 1. Row 4 column 6 is a 1. Yes, okay, so what you do is you look, this is an indexing puzzle. Apparently these puzzles are beloved of computer programmers who understand these things very naturally. But let's make this square a 5, for example. If that square's a 5, that's telling us that the 1 in this row goes in the 5th column. So this column is always indexing the 1. Now, I think, yeah, the same applies to columns 5 and 9 with the digits 5 and 9 respectively. So this column is telling us where the 5 goes in each row. So if this was, if that was a 2, that would be saying that the 5 in this row goes in the 2nd column. So it's fairly straightforward once you get your head around it. This column's doing 9s, so let's make, I don't know, let's make that square 4. If that square's a 4, that's telling us that the 9 in this row goes in the 4th column, so we put it there. So it's fairly straightforward. And then these are just region sum lines, which have exactly the same rules as the Pluto puzzle. So digits along a blue line have an equal sum n within each 3x3 box now the line passes through. Different lines may have different values for n. So yeah, I mean, it's exactly the same as the other puzzle. It's just this line here looks a bit more complicated, doesn't it? In fact, we could probably do some colouring just quickly, just so that we can understand exactly how this region sum line works. So let's, oh, that's very unpleasant colour I've managed to construct there. Let's do, no, okay. So it's a bit difficult to make this colour work. Let's go, oh, I don't know. I don't actually have a good option. But basically what we're saying is each of these little coloured regions have to have the same sum. So those two digits have to have the same sum as the orange digits, have to have the same sum of the yellow digits, have to have the same sum as the green digits, etc, etc. So that is how we're going to solve this puzzle. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now, I think I might have to share a secret with you first. I'm not sure. I'm not sure what the right way to solve this puzzle is, but I will tell you, I think, the secret I know about region sum lines. And this is a secret I didn't know, actually, until I'd done a couple of these. And some very clever people in the comments said, you need to think about 159 rules with in a particular way. And once I understood this secret, it's really powerful. So whenever you come across a puzzle with these 159 stripes in, I would recommend thinking about this trick. And the trick is that, let's just take these cells as an example. Those three cells have to exhibit entropy, by which I mean one of these digits has to be a low digit, a 1, 2 or a 3. One of these digits has to be a 4, 5 or a 6, and one of these digits has to be a 7, 8 or a 9, which is not immediately obvious when you start doing these puzzles, but once you think about it, it makes sense. The reason is, let's try and make two of these digits middly. So let's try and make that a 4 and that a 6, for example. So this is two digits in this little stripe of 3 that are from the middle set of digits, that are from the digits 4, 5 and 6. Why does this fail? Well, what this 4 is telling us is that we need to put a 1 here in the 4th column. The 6 is telling us we need to put a 1 there in the 6th column. And you can see immediately you get two 1s in box 2. So it doesn't work. It's exactly the same if we go 7, 9 here. We'd have to go 1s in those positions. So what we have to do is to ensure that that each of these little 3x3 rectangles exhibits entropy. And that's something I'm going to be keeping an eye on. Now, the other thought I have with this puzzle, which I noticed when I was doing the colouring in the example, is that there's quite a big mismatch between the length of the region sum line in some of these boxes. So in this box here, the long region sum line only has a domino of digits in it, 2 digits. But in this box, the region sum line takes 5 digits. Now, the minimum sum of 5 digits is 15. And that means this domino has to add up to at least 15, which means it definitely has to be from the digits 6, 7, 8 and 9. We can't put 5 and 10 into these two cells. Now, okay, so we're going to be able to repeat that there. Look, that's a domino, isn't it? And this line has, this line is well, it's very symmetrical, actually. Isn't it? It's a very symmetrical line, so we're going to get exactly the same profile there. So these 3 digits and these 3 digits individually need to add up to 15 as well, or more. Now, right, so the next thought is, can we make, I mean, we're going to have several low digits on this purple sort of Z pentomino, aren't we? Because while we could make yellow add up yellow and these dominoes add up to 15, we can't make them add up to much more than 15, because we can't make them add up to more than 17 even if we make them an 8-9 pair. So this has to have 17. It's probably got to have 1, 2 and 3 on it, I think. Yes, if it was 1, 2, 4, 5, 6, it would add up to 18, and that's too high. So it does have 3 on it. So it's got 1, 2 and 3 on it, and then it's never got 8 or 9 on it. So 8 and 9 in this box are in those squares. Ah, of course, yeah, but okay, all right, okay, so now I use my entropy trick, don't I? Right, remember what we said? We said that each string of each of these 1x3 rectangles, or 3x1 rectangles if you prefer that, has to have a low digit on it. Well, which is the low digit in that string? It's got to be the central square of the grid, because these two can't be 1, 2s or 3s, because then this line would add up to too much. So this is a 1, 2 or 3. This is indexing the 5 in this row, so it's telling us there is a 5 in one of those 3 squares. I mean, it's not the most massive deduction, but it's very cute. Okay, there is a lot. Right, I've spotted 2 different ways. Yeah, I have. I've spotted 2 different ways of proving that proving that the region sum line has a total of 15 exactly, actually. Now, which way would you like to see? See if you can spot 2 different ways to do it. Okay, the reason is, let's do the sudoku based reason first, which is the second way I spotted it. If these 2 dominoes here have the same composition, so imagine this was a 9-8 pair, this would be a 9-8 pair as well, because we know we would be heading up for a 17 total on the line. Now by sudoku, if this is 9-8 and this is 9-8, there's a 9 and an 8 on the region sum line in this box, and that would require the other 3 digits on this Z pentomino to all be zeros, and that doesn't work. So it's not possible for the composition of this domino here to be the same as the composition for this domino here, and that immediately rules out 17 as an option for the line, because that's a 9-8 pair, and 16 because that's a 9-7 pair. There's only one way to make those totals. So we have to be going for a 15 total. Now the other way of seeing that is by entropy, because imagine that it was 17 was the total. Well, if it was 17, we'd have 8s and 9s here, and that would require this little 3x3 here to contain an 8 and a 9, and that would break entropy, because that's going to require a 1 or 2 1s to appear in this box, because one of these will be an 8. Let's say it's that one, that will put a 1 there, and one of these will be a 9, and that's going to put a 1 there, and there'll be 2 1s in box 3. So this doesn't work at all, and that means that out of nowhere we find that the total for this line is exactly, right, the total for the line is exactly 15. So we can therefore address what's going on in the middle box, which must be a 1, 2, 3, 4, 5 quintuple, which means these are 6, 7, 8, 9, these are 6, 7, 8, 9. We've got quadruples now in this row and this row. But beautiful. This is beautiful. Right. Look at this box. And think about the entropy rule with these 3 digits. Which is the middle digit? Well, we know one of these has to be from 4, 5 or 6. Because we've got the low digit, we need a middly digit. So one of these is a 6. And if one of these is a 6, it's indexing the 5 in its row. So one of these is a 5, and that one can't be a 5. So that one's a 5, which means that one's a 6, which means that's not a 6. These aren't a 6. And we're suddenly away here. We've got 6 is knocked out of these squares. Right, and these have to add up to 15, so they've got to be a 7-8 pair. This now cannot be a 7-8 pair, because that would put 7 and 8 in this rectangle here. And that's going to put 2 9s in this box. So this has to be a 6-9 pair. 7-8 means this is a 9. So we're going to get lots of things from this, because this 9 is in column 4. So we can write 4 in here. We get a 1, 2, 3 triple at the start of the row. This little region sum line is like the one in the Pluto puzzle. So it's basically saying those two digits are the same, isn't it? So those two can be labelled up 1, 2 and 3. This line adds up to 9. So that digit can't be 5 anymore, because we can't add 1, 2 or 3 to 5 to get 9. So this is 6, 7 or 8. These two squares are a 7-8 pair, so these two squares are a 6-9 pair, so this is not 6. So this is not 3. So this is either a 7-2 pair or a 1-8 pair. And for our next trick, this square now is not 3, because this was indexing the 5 in the row. So there's now a 5 in one of these. There's a 5 in one of these 3. Oh, hang on. No, this 7 or 8 is indexing the 5 in the row, isn't it? So the 5 has got to be in one of those two positions. 9. Oh, look, 9 in row 5. It can't go on this region sum line, because then this would have to be a negative number to add up to only 7 or 8. So 9 is in one of those two positions. Now, if... that's gorgeous. Right. So 9 is exactly here. Because if 9 was there, we'd have to put 8 in here to indicate that the 9 in this row was in the 8th column. And I know this is a 7-8 pair. So 9 is not there. 9 is here, which sort of indexes itself, doesn't it? Okay. Okay, that cell is a naked single. Don't say that we don't get frivolity and innuendo in Sudoku. This is a naked single, because if we look at it, it sees 6, 7, 8, 9 in its row. It sees 1, 2, 3 in its box, and I've got a 5 pencil marked here, so the only thing this can be is 4. That's indexing the 1 in the row, so this is a 1, this is a 2. That's indexing the 5. Here we go. We're off to the races here. This is now a 7 or... this is a 7 or an 8 by Sudoku. And that's indexing the 1 in the row, so there's a 1 in one of these two squares. We can take 1 and 2 out of this box. We know exactly the Sudoku Sudoku contents of these boxes by Sudoku, because we've effectively got 6 digits in row 6 sorted out already. So this is 2, 3, 5. This is 1, 6. And that can't be a 1. If this was a 1, we'd be adding at most 5 to it, and 1 plus 5 does not equal 7 or 8. There is a knowledge bomb for you. So this square here has got to be 6, which means this is 1, which means that's 8, because we've got to index this 1. This is 7, so this is 2 by mathematics. We've got a 1, 3 pair here. This now is also 1 or 3. Oh, and this can't be 3, because that would say put a 1 in the 3rd column, where I've now got a 2. So this is 1, this is 1, this is 3. And this is actually a very Blobz-like puzzle. Blobz puzzles are typically not the most monstrous things you've ever faced in your life, but very, very enjoyable. Now, how does this work? I must add 2 to this, because anything else is going to be too high. That gives me a 7 here. So that gives me a 5 here. This square's a 3 by sudoku. That puts a 3 on the line. No 3 in the corner there, all there. Can we get a 3 in the corner over here? Yes, still possible. Still possible in one of those positions. So we are in the unusual situation today of possibly having 2 songs. 6 here means this is 6. This is 9. Ah, look at row 3. We can do lots of indexing. The 1 is in column 2. The 9 is in column 7. Sorry, now I'm stuck. I sort of want to pencil mark those digits because I want to think about the 5, 3, 4. That square is not 5 or 8. That's only 3 or 4. No, that was... Oh, hang on. What? This is indexing the 5. Oh, no, actually that's... Oh, well, that can't be 8 then, because that would put the 5 in the 8th column where it can't go. Okay, no, that's really unhelpful. Sorry. Oh, that's evil as well. I was wondering whether we could use entropy to fix these squares. But that could, it's possible, unlike over here, where I think we had a 7-8 pair, and I could then eliminate 7 and 8 as the option to make 15 here, because that would have put 7 and 8 in the bottom 3 squares here. If this was 6 and 9, that actually, I mean, it's not going to be that from a uniqueness perspective, but that could work from an entropy perspective. So I think, although that's not 7, which means that's not 8. Okay, so how do we do this then? We could argue about Maverick flying over. There's a 9 in one of these 2 squares by sudoku, which means there's an 8 in one of those 2 squares by sudoku. There's a, oh yeah, hang on, look, there's a 6 in one of these 3 squares, so that's indexing a 9 into one of those 3 squares. It doesn't do anything, it's so annoying. Oh, hang on, I've got a 3-4 pair in column 6. I hadn't noticed that. 1, 2, 6, 7, 9. Is that worth pencil marking? Oh, actually it is. It is. I've just seen one thing I can do as a result of that. So this square is 1, 2, 6, 7 or 9. But where is the 9 in this box now by sudoku? 9 is in one of those squares. Now these 3 squares add up to 15. So that's definitely not 9. And now I think about it, it's also not 6 or 7, is it? Because if this was 9 and this was 6, we'd have to put 0 on the line to add up to 15. So this square here is, oopsie, this is 1 or 2. And these 2 squares, so yeah, so basically what's happening is, we've got a 9 on this, in this little triumvirate, this triomino, and we've got 2 digits that add up to 6. So it's either 4 and 9 or 5 and 9. Oopsie, this is not 4 or 5. This is 1 or 2. This is either 4, 2, 9 or 5, 1, 9. Three, 4, 5. Yeah, okay. And look at those. Look at all those digits together now. 3, 4, 5, and 3, 4, 5, 8, and 9 are a quintuple in box 2, which means the other squares are 1, 2, 6, and 7. Which that might be interesting. I'm definitely going to record that. Oh, I've just spotted something far more obvious. Hang on, I'm going to tell you what that is. 1 is not here. So 1 is in one of those 2 squares, which must be indexed by a 6, mustn't it? So there must now be a 6 in one of these squares. Which would work with this being 6, 9, actually. But anyway, that's not the thing I noticed. The thing I suddenly thought about was, what about entropy here? because the 4 or the 5 are a middly digit, the 9 is a high digit, so we need a low digit in this triple. And this square must be the low digit and has to therefore be a 3. That gives me a 4. The 3 tells me the 5 is in the third column, so we get everything done just in an absolute flurry of maniacal glee. Okay. The 4 then comes out of this line. So this is now a 5, 9 pair, which means this square's a 1, which is therefore means that square's the 6. So this is not a 1 anymore. 9 is in one of these two squares, so there must be a 5 in one of those two squares to index it. So these squares have to include a low digit, don't they? So it's got to be a 1 or a 2, so these are only from 1, 2 and 5 because they can't include 3. So there's a 9 in one of those 3 positions. That digit has to be a 7 or a 9 because it needs to be high by entropy and it can't be 8. So that's telling us there's a 1. Yeah, sometimes I find with these 159 puzzles, that's not 1 anymore, that you find that they're sort of self-referencing. You discover some logic in it, but you find you've already got that logic via a different source if you'd thought about it properly. Now, okay, well, what we should do is probably look at these squares, which have got to be from 1, 4 and 8. Okay. Yeah, alright, this is not a 1, 4 pair, because then that would have to be a 10 to get us up to 15. So there must be an 8 in one of those squares, which means this square is not 8. So this is 1 or 4. So this is pinpointing the 5 in this row, which is now either here or here. I do not have a good way of pencil marking that across boxes. Oh, hang on, I know how to do. Oh, this isn't 6, 9. Ah! Okay, right, I'm right. 8. Where is 8 in this row? I've got an 8 in one of these two squares and an 8 in one of these squares. So I know 8's not in those 6 cells and 8 is not there. So 8 is on this domino, which adds up to 15. So this is a 7, 8 pair and we know the order. So this is 7, this is 8. So that's putting 7 in the corner, which is putting 7 here. And oh, look, and the 6 and the 7 are, well, the 6 we've done. The 7 is going to give me a 1 here in the 7th column. That's placing a 3. That's placing another 3 up here. 1, 2, 3, 4, 4, 8, 9 into these squares. But didn't we work out that the... Yeah, this can't be a 1 anymore, obviously. So this has become a 2, 5 pair. That's probably going to be helpful. These squares have got to be 4 and 8. So there is a 9 in one of these squares because the second column, whichever one of these is a 2, is putting a 9 in one of those. So this square here is... So now I've got a 4, 8 pair there, which makes this the 9. Okay. Makes that the 9. Put the 9 in. So this square now needs to be a 2. This is the 5. This is a 5. This is a 9. This is an 8. This is a 4. This is a 4. This is an 8. This is an 8. This is a 7. This is a 4. This is a 3. Here we go. This is a 9. This is a 6. The 9 needs to be... the 9's already been done for ages. I just didn't notice it. That's classic me when it comes to 159 puzzles. The bottom of column 1 has got to be 3, 5 and 9. Oh, 3. So there is still a chance for 3 in the corner. In fact, there's now even a better chance because of this 3. We're in one of two possibilities. One of two... Well, we've got a 50-50 chance because the 3 is definitely in one of those squares. This is a 5 or a 9. So the 1 in this row is either there or there. Oh. Okay. What are these digits? 1, 6, 8. And we know this is not 8. Oh, I see. Yeah, no, actually, I haven't learned anything from that, actually. Strangely. Oh, hang on, I can get this digit. I should have done this before, shouldn't I? Look, I know there's an 8 on here, so the other 2 digits have to add up to 7, and I know the other 2 digits are either 1 or 4, so this is 3 or 6, and it is apparently not resolved, actually. Oh, okay, but if that's 3 or 6, it's not 5, so that's not 4, because if this was 4, it would put a 5 here. Okay, right. I think I've just got to do Sudoku now. I think we're basically finished with the puzzle. I've just got to 2, 4, 7. Oops. That's not 7. There's going to be some, you know, pair or something in one of these rows that's going to just sort out this our last little conundrum. 2, 6, 7 and 9 into these squares, so that's 2, 6 or 9, and this column needs 2, 3, 5, 6. Again, I can eliminate some things. Let's just study row 7. I feel like that's where we're going to find the most traction. So, sorry, I can't quite see how to do this. No, okay, all right, I think that's right. We're going to carry on pencil marking. So these are a 2, 4 pair. And these are a 1, 6 pair. Oh, okay, yeah, so there we go. Now I've got a 1, 6, 8 triple in this row. So this square here has to be a 3. And therefore that square's not a 3. Got it. That's 3 in the corner, that's 3 in the spotlight, losing its religion. Very nice, very nice. Hang on, so can we use this 1, 6, 8 triple even more? Oh no, hang on, if that's a 3, it's indexing a 1, isn't it? So that's 1, that's 6. Is that doing any extra rinky-dinkage? Perhaps. These 2 squares have to add up to 12, and we know one of them's an 8, so it's got to be a 4, 8 pair, and we can see the order. So that's 8, that's 4, that's 1, that's indexing 5, so that goes, the 9 goes over here. This is now a 6, so we need to put a 9 here. How does that work out? Oh, the 1 and the 8 are also done. So the 8's telling us we need to put a 9 here. That gives us a 5. 8 here is giving us a 5. The 4 here is giving us a 5 there, which we didn't have before. This 4 is huge. So 4, 2, 7 here, 2 here, 4 here. This is 2, this is 2, this is 6. And we need a 7 and a 9 to finish the puzzle, I think. And that, I believe... Oh, I made a mistake. What have I done wrong? Oh, I've put 2 9s in here. That's not sensible. Is that literally the last? Oh, look. I didn't clean up my pencil mark, so I thought I was looking for a 9 here. In fact, no. That is probably going to be better. Yes. Wonderful. Save replay again. Only 6 people have done this one in 36 days. Why so few people? That's a beautiful puzzle. I absolutely love that. It wasn't terribly difficult, but well, let's say that. It'd be interesting to find what Tony thinks of this one, because it's not terribly difficult if you know about entropy. If you don't know about entropy, how would you break in? No, you can do it. You can use sudoku to find that the total is 15. And if you know the total is 15, you know this is 1, 2, 3, 4, 5. And then you know that, yeah, well, then maybe you just have to think a bit about 5 in this box and what's possible. Yeah, so you can probably do it without entropy, but I think entropy makes things very clear, doesn't it? And that, well, I have to say, I found that extremely enjoyable. Blobz, I hope that you have a great birthday, my friend, over there in California. Oh, I've just remembered. You sent a cake picture, didn't you? I was meant to show this and I didn't. Look at this. This is so remiss of me. Look at this. I don't know if this is real, but the testers who recommended the puzzle said that this is the birthday cake of... Hang on, let's just stare at that for a moment. I've got it in my head. Go away. It is the same, isn't it? I think it's the same. Let's restart the puzzle. I think it'll be easier to see if we go back to the picture. It is the same. Oh, that's just so cool. If that is your birthday cake, that is the best birthday cake I have ever seen. Yeah, that's magnificent. That is magnificent. Hats off. You win. You win the internet today, Blobz. Let me know in the comments how you got on with the puzzle. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.